Hello, we're going to continue on with functions today. I have given you two different function foldables. Both of those are kind of a review from yesterday. If you'll look here, it goes from the functions to the mapping diagram, which is just a different kind of table. We won't use that one very much. And then a table and a graph. Remember, we're really going to be focusing on tables and graphs for this unit. So just to show you what a function will look like compared to not a function. So that's going to go into your journal on the very next page. And then the page following that, you're going to put in this foldable, which is one of the stair-step foldables. Notice the order. Make sure you put them in the right order or the examples will not make sense. Okay. This is also a foldable on functions. Showing you what it is, how to graph it, how do you write the rule. Okay, so those are just some review foldables for you. Okay, on the next page in your journal, you want to set up your journal like this. Okay, so you should have those two foldables, and then this will be the next page and the next page. So this is page 3 and 4 that you're putting in your journal. I've given you these graphs. You can just draw your own T-charts. So I'm going to give you some equations to work, and then you're going to make a chart for them, and then a table. So we're going to go from an equation to a table to a graph. Okay? All right, so this is how you should set up your next two pages. This blue line is the middle of a page. So here's a page, here's a page. Okay? All right. So let's talk about how to graph a function. Okay, so on your first graph, so going back here, so on this first graph, we're going to put this example. Okay, so we are going to do y equals negative 2x plus 1. Okay, so in your T-chart, you're going to have your x and y. Remember, I like you to do negative 2, negative 1, 0, 1, 2 if there are no numbers provided for you. Okay, so we're going to plug in these x's to this equation to figure out what our y's are. So negative 2 times negative 2 is 4, plus 1 is 5. Negative 2 times negative 1 is 2, plus 1 is 3. Negative 2 times 0, 0 plus 1 is 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. Negative 2 times 2 is negative 4, plus 1 is negative 3. You will notice it's going down by 2 each time. So that means it is a linear. Okay, that can just be something in your mind that you can say, oh yeah, that's linear because it's going up or down by adding or subtracting. Okay, so on your graph, you are going to go and graph these points. So this is your ordered pair, negative 2, 5. If you need to rewrite that as negative 2, 5, go for it. Okay, that's totally up to you. So on your graph, we're going to graph that. I'm just going to kind of estimate it here. So we're going to go negative 2, up 5. 1, 2, 3, 4, 5. Now yours will be exact because it is not going to be estimated like mine. All right, negative 1, and then 1, 2, 3. 0, 1. 1, negative 1. And then 2, negative 3. Okay, and then we will connect the dots. Okay, so you have just graphed this equation. So here's the graph, here's the table, here's the graph. This is the equation, sorry. Graph, table, equation. All right, so on your next one, we are going to do another example. I'm going to erase this real quick. Okay. All right, so on your next one, so you've done this 1, 2, 3. Okay, so on number 2, we're going to do y equals 1/2 x minus 1. Okay, so from that we're going to do our table. Remember, negative 2, negative 1, 0, 1, 2. We're going to plug these into this equation. All right, 1/2 times negative 2 is negative 1 minus 1 is negative 2. Okay, 1/2 times negative 1 is negative 1/2, minus 1 is negative 1 1/2. 1/2 times 0 minus 1 is negative 1. 1/2 times 1 is 1/2, minus 1 is negative 1/2. 1/2 times 2 is 1, minus 1 is 0. Okay, this one's a little bit more tricky because on your grid you kind of have to use some half marks, which is okay. We are perfectly capable of doing that. Okay, all right, so negative 2, negative 2. Okay, negative 1, negative 1/2. So you're going to go kind of like right in the middle. Okay, 0, negative 1. Okay, 1, negative 1/2, 2, 0. Okay, connect the dots. Okay, so we have went from equation, table, to the graph. Okay, all right, so let's continue on. Okay, sometimes you'll have real world applications. I just put this in there for you to look at. They've given me the equation with larger numbers. Okay, they've made a table. Okay, and then they've made the graph. Notice they have changed the intervals on the X and Y axis. You can do that. So if you have really big numbers, you could make your chart like 2, 4, 6, 8, 10. Or you could make it 10, 20, 30, 40, 50. That is totally up to you. Because if you had to graph something with 20,000, it would be very, very high up. So just change your intervals to make it work. Okay, so I just wanted to show you this example for a real-world application. Okay, all right, so on the other side of the page, so you had done 1, 2, 3. Your title for that one is going to be Graphing Linear. Whoops. Okay, on the other side, we're going to graph nonlinear. Is going to be your title for those two graph pages. Okay, we are going to do the exact same thing. Okay, we're going to do the exact same thing using an equation. So our first equation is going to be y equals absolute value of x, close it, minus 4. Okay, so we're going to make our table. We can do negative 2, negative 1, 0, 1, 2. Okay, so negative 2, absolute value of negative 2 is 2, and then minus 4. 2 minus 4 is negative 2. All right, absolute value of negative 1 is 1. 1 minus 4 is negative 3. Okay, absolute value of 0 is just 0. 0 minus 4 is negative 4. Okay, absolute value of 1 is 1 minus 4. 1 minus 4 is negative 3. Absolute value of 2 is 2. 2 minus 4 is negative 2. Okay, so then we're going to go to our graph. Let me clear off this. And we are going to graph it. Okay, just use your points. So we have negative 2, negative 2, negative 1, negative 3, 0, negative 4, 1, negative 3, 2, negative 2. Okay, and then we just connect the dots like we have been. This is an absolute value. Absolute value will always make a V shape. If you only get one side of it, you have to continue your numbers, but we won't focus on that yet. Okay, so we went from an equation to a table to a graph. Okay, all right, so let's continue on, and let's do y equals x squared plus 1. Okay, we're going to do a table. We're going to do negative 2, negative 1, 0, 1, 2. All right, so negative 2 squared. Remember, it's negative 2 times negative 2, which makes it positive 4 plus 1 is 5. All right, negative 1 squared, negative 1 times negative 1 is positive 1, plus 1 is 2. 0 squared is just 0, plus 1 is 1. Okay, 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. Okay, this one's really a little different. Okay, so we're going to do negative 2, and then 5. I'm guesstimating again, you're not going to. Negative 1, 2 is here. 0, 1. And then 1, 2, and 2, 5. Okay, you'll notice this one, if I connect the dots, makes a U shape. Okay, so this one's not exactly straight. Okay, all right. So that is your second example. We went from an equation to a table to a graph. I'm saying that over and over because that is the method that I want you to use. Okay, so what I want you to do is you are going to do this one on your own on the third one. Okay, so we're going to do y equals x cubed plus 1. Okay. Okay, so we're going to do our table, negative 2, negative 1, 0, 1, 2. I'd like for you to pause it and try to do it on your own, and then I'm going to continue with telling you how to do it. All right, so negative 2 cubed. Remember, that's a negative 2 times negative 2 times negative 2, which makes it negative 8. Plus 1 is negative 7. Okay, negative 1 cubed is negative 1, plus 1 is 0. 0 cubed plus 1 is 1. 1 cubed is 1, plus 1 is 2. 2 cubed is 8, plus 1 is 9. Okay, all right, so this one's graph is a little different. It's going to go off your graph just a little bit, but do your best. Okay, negative 2, negative 7 is going to be down here. Negative 1, 0 is right here. 0, 1 is here. And then 2, 9 is way up here. This is that one that I told you kind of looks like a chair. Kind of goes like this, okay, because it is cubical. So that is this example. All right, so we have to look at something called continuous and discrete graphs, which is an easy concept but hard at sometimes. So I am going to actually put it in a second video because my time is just about out. So if you would like to go ahead and make this foldable on the next page, okay, this is the one that you kind of cut in the middle, okay, and then you should have this on one side and this on the other side, okay. All right, so if you will put that in there, and then you're going to start on the second video for this topic. All right, thank you.